Continuing from our last video of 12.3, we were talking about odd degree versus even degree and about some terms. I want to mention two quick definitions with this. The first one being the turning point. Polynomial function of degree n has at most n minus 1 turning points. So basically what that means is whatever the degree is of the polynomial, if you subtract 1, that's at most how many turning points it could have, with at least one of the turning points between each pair of successive zeros. And I'll explain that second part in just a second. The dominating term is the other definition, and that's defined as the function of x equals a sub n x to the nth power of a polynomial. This determines the end behavior. So basically, knowing what the leading coefficient is and what the degree is, we can determine what direction the graph starts and what direction the graph ends, whether it's pointing up, down, as it's going continuously. If we look back at those graphs up here, you'll notice that this peak point right here on this first graph, that is considered the turning point. And this right here is the P or another turning point. So with a degree of 2, this one does have 2 degrees. Now what we did see in previous examples, like in this first one that we did in 12.3, this one had a degree of 4, but you'll notice it only has 1 turning point. And that's fine, as long as it doesn't exceed 3 turning points, it could have less than that. So now getting to the dominating term and talking about the end behavior of the graph. We briefly talked about the degree of it, and how they'll face away from each other. And if the leading coefficient is positive, then the arrow will start down and then end up. So they're facing away from each other. This will look like the first graph in 7a. If it's odd, but the coefficient is negative, that leading coefficient is negative, the arrow will start up and then at the end go down. That's because it's reflected over the x-axis. If it's even, we talked about how they're going to go in the same direction. So if the leading coefficient is positive, they're both going to be pointing up. If the degree is even and the leading coefficient is negative, then they're both going to be down. Now, we saw this last one right here in that first example as well. Notice that the degree is 4, and so, but the coefficient is a -1, so it starts down and it ends down, and that's what it refers to as end behavior. We're going to start actually sketching our own graphs of these polynomials. And in order to make a comprehensive graph, I'm going to be checking for 4 things. The first thing is we're going to check for all x-intercepts. So we're going to use some techniques that we saw in section 12.2, when we were trying to find the zeros of the graph. So those are the x-intercepts. We're then going to try to find all y-intercepts, and that will just be by substituting in 0 in for x. From there, we're going to find the turning points, and I'll explain that once we get there. And then we just want to make sure that we show enough of the domain to show the end behavior. Again, if they're going up, down, at the beginning or at the end. So when we start with number 3, what we're going to do is we're going to check to find all x-intercepts. And in this particular one, we were told what one of the zeros is. It says that given that 0 is a 0 of the function. So we're lucky in the sense that it helps us to figure that out. Now, if we weren't given that, we would have to either try to factor it or use the P over Q that we talked about in 12.2. So knowing that 0 is a function, that should make sense because each of these have x in the terms. I'm going to use synthetic division. And notice that I'm putting 0 there for the constant. And we're going to knock this down from degree of 3 to degree of 2. So 3x squared minus 3x minus 6. And from here, I'm going to try to find the solution. So I can do this a number of different ways. I can either factor it, or I can use the quadratic formula, or I can do completing the square. This one, I'm going to take out a 3. And I'll notice that this is actually factorable. X minus 2 and x plus 1. So we get x equals 2 and x equals negative 1. And here's one solution, here's the other, and we were also given x equals 0 at the beginning. So these three numbers right here tell us where the x-intercepts are for the graph. Another thing that we're going to know about this is because it has a degree of 3, it means it's an odd function. And because the leading coefficient is positive, if we go back to the chart up here, because it's odd and positive, the left arrow is going to be pointing down and the right arrow is going to be pointing up. So what's going to happen, and this is just looking at it from a number line perspective, it's going to cross at negative 1, 2, I'm sorry, this should be 0 and 2. And what's going to happen is it's going to come up from this way, and it's going to have some kind of intercept, and it's going to turn, cross at 0, turn, and come back. So you'll notice that there's 4 sections. Here's 1, 2, 3, and 4. So there's 4 parts. And what's going to happen is that halfway in between here, there's going to be a turning point. Now, as of right now, we don't exactly know what those are, but we're going to figure those out based on the sections. So what we're going to do is I'm going to use these sections to kind of help me figure out a t-chart. And I should kind of point out real quick that in step number 2, it says find all y-intercepts. Well, in this case, it happened to be that the x and the y are the same intercept. So we can skip that step. Otherwise, you would set it equal to 0 or plug in x for 0 and then solve. But what I'm going to do now, so once I find the intercepts and I see how many sections there are, I'm going to look at each section. And I'm going to pick a number on the left for section 1. So let's say I pick negative 2. And then in section 2, I'm going to pick a point halfway in between because that will give me the turning point. So negative half. And then in section 3, I'm going to go halfway in between here. I'm going to put 1. And then in section 4, I'm going to pick just a number outside of there. And this will give me a pretty comprehensive graph because it's giving me some points in between. And again, I'm going halfway between to get that turning point. So I'm going to take negative 2, and what I'm going to do is I'm going to take negative 2 and plug it into my function. So each one of these x's. When you plug in negative 2, you will get negative 24. So you can take a minute and plug in, make sure you get negative 24. When you take negative half and you substitute it in for x, again, into that function, you're going to get 1.875. I'm going to do the same thing with 1. When I plug in 1, I'm going to get negative 6. And then when I plug in 3, I'm going to get 36. So now I'm going to go to the graph, and you'll notice that some of these won't be on there, and that's fine. I'll just show kind of the distance. I'm going to start by plotting my intercepts, negative 1, 0, and 2. And then I'm going to plot these other ones. Well, negative 2, negative 24 is way down here, so I'll kind of put something down there. And like we talked about for the end behavior, it's coming up because it's odd, and it was leading coefficient was a positive. And then at negative half, it's 1.87. So I'm just going to estimate where that point is, and that's the turning point. And it's going to come back to intercept. And then at 1, it's going to be at negative 6. That's going to go back down here, and then that end behavior puts it back up to here. So I just want to quickly recap what we do to get a comprehensive graph for this. I'm going to find all my x-intercepts, and again, that might mean finding the p's over q's, and then using synthetic division to actually solve for, um, knock down the polynomial a few degrees so we can solve it by factoring or quadratic formula. So I'm finding those x-intercepts, I'm plotting those, and then I'm finding a value in between each of those sections to plot the points and graph. So, and I also need to make sure that I understand the end behavior, meaning it's an odd degree or odd or even degree, and what the leading coefficient's going to be.